Forget the cold red desert you see today, because Mars was once a dramatically different and surprisingly vibrant world. About 4 billion years ago, the Martian atmosphere was much thicker, effectively trapping essential warmth across the surface. This thicker blanket meant temperatures were high enough and pressure sufficient to allow stable, liquid water to exist freely outside. Imagine an ancient Mars where this flowing water spent eons actively sculpting the planetary surface in powerful, sweeping ways. We can still observe the clear remnants of ancient river channels and massive valleys carved deep into the rust-colored plains. Vast bodies of water, perhaps even a large global ocean, likely filled the enormous northern lowlands of the planet. Where that water once pooled and flowed, it chemically altered the rocks, creating specific minerals that only form in wet environments. All these incredible hydrological features point toward an early Martian climate that felt very similar to a young, thriving Earth. Beneath this water-rich surface, Mars was also a place of immense geological unrest and powerful internal forces. Massive, fiery volcanoes frequently pierced the sky, including the colossal Olympus Mons, the largest mountain in our entire solar system. Crucially, the planet's hot, active core generated a strong, invisible magnetic field that acted as a vital shield. This powerful shield successfully deflected the relentless, damaging onslaught of the Sunday's intense solar winds. Having that atmospheric protection was absolutely key to Mars retaining its precious water supply for such a long time. However, as billions of years passed, the planet's internal engine began to slow down significantly. That gradual cooling caused the protective magnetic field to fatally weaken and ultimately vanish from existence. Without the magnetic barrier in place, the solar wind began ruthlessly stripping away the thick, insulating atmosphere layer by layer. Consequently, the surface water either boiled away into space or froze solid, permanently locking away beneath the dry crust. The once dynamic world slowly transformed into the cold, arid planet we are currently exploring today. This ancient, water-rich Mars was clearly a dynamic and potentially habitable place for some form of early life. Today, those preserved ancient landscapes hold all the critical clues about that very different, watery past. We continue to search those dusty plains, hoping to find confirmation that life once had a chance to truly take hold.